Hi, Sam from Roberts Geospatial here, just making a Steven Spielberg style making of video for my bauxite investigation. So just want to show you the technology that's in ProRaster Scientific that I'm developing that was used to generate the imagery for that video. So I've got ProRaster Scientific running up there. In order to make that video, the first thing I did is I went and downloaded a whole bunch of Landsat scenes from the USGS in the normal way. And so you download those scenes, you unzip them, you get some files. They're all TIFF files, one per band, and they will go into separate directories. So what ProRaster then does for you is that it imports that TIFF file, that scene, each scene, and it creates a virtual raster for each scene. So let's just take a quick look at that. Recall that a virtual raster is just a small XML file which describes a raster. So here's a virtual raster for our 2022 scene. So I was using here surface reflectance. So this is bottom of atmosphere. And you can see in the field list we've got our bottom of atmosphere spectral bands and our thermal bands. These are the digital numbers, so this is the data that's coming directly out of the TIFF files. Then we've got our reflectance and temperature. Now these data are scaled and transformed according to metadata that's in the Landsat scene. So that scaling and transformation gets performed on the fly when you do anything with these virtual rasters. And then we have the ancillary data, other rasters that were supplied with that scene, the QA. There's all your QA pixel values and radiometric saturation values. And finally, we have our mask field, which we can use to mask out cloud and water and so forth. So that's our first product, a virtual raster for each scene. So then use ProRaster Scientific to create a rendering algorithm for the scene. So I'll just drag one of those in. So this is a natural color rendering algorithm for that scene. So we have our red, green and blue connected to bands 4, 3 and 2. That's just standard for Landsat 8, and you can see that we have this sort of natural color rendering. I've chosen here the spectral bottom of atmosphere reflectance. So this is the scaled values. So when I display this on scene, what's happening is it's coming from the TIFF files, it's going through that virtual raster, it's getting scaled and transformed, then going into the rendering algorithm and being colorized and displayed on screen. So in order to get coverage from 1974 right through to 2022, I had to go to a whole bunch of different Landsat satellites and products. So most of it is Landsat 8. It's all collection 2, and all the Landsat 8 and 7 and 5 data is surface reflectance. But then as you go back further to Landsats 1 and 3 and 4, then we're using level 1 data. Still collection 2, but level 1, just digital numbers. In that case, the data has been processed to top of atmosphere. So we've got Landsat 8, Landsat 7, Landsat 1, Landsat 3, Landsat 4 and Landsat 5, all sorts of different scenes. So to then put that together into a series, a time series, there are kind of two ways to go about it. So firstly, if you had data that was all the same, all the band structures and everything were the same, then you could link directly to those virtual rasters as your source raster for each point in the time series. But in this case, I don't have that. I don't have that situation. I've got different combinations of bands. The Landsat 1, for example, uses some kind of false color rendering band combination, whereas everything else is natural color and so forth. So what I ended up doing is creating a virtual raster for where each event in that virtual raster is actually one of the rendered scenes. So let me just explain how that works. So in this system, rasters can have a time dimension, and they're called events. So at each event, there is a time, and then there is data recorded at that event. In ProRaster, if you look up here on the screen, you can see that there's a time range, and you can choose your beginning time and your end time. And usually there's only one value in there because there's only one event in any kind of normal raster. But if you use a virtual raster, it's actually very easy to create multiple events. And once again, this is just a processing on the fly. The virtual raster just brings in that data from the source rasters as required. And the second concept to understand is that a rendering algorithm, which gets stored to a MRD file, again, that's just an XML file, that can be treated as though it's a raster. So it's a virtual raster in itself. Now, virtual raster can draw data from rasters, or from other virtual rasters, or from rendering algorithms. And a rendering algorithm looks like a raster that's got an image field and a RGBA color data band. So you can make algorithms recursive. They feed off other algorithms, rendering algorithms. So in order to display these images in a time series, I created a virtual raster which has a bunch of events in it, and each event links back to a rendering algorithm for a scene, and and then it all gets displayed. So let's have a look at what that looks like. So let me drag this one in. I've lost it. Here it is. So I'm dragging in a virtual raster. It takes a little while to open. When it does, you'll see that we get a image field because the virtual raster has got a bunch of MRDs in it, so it's essentially a bunch of images. So it says, okay, I've got an image, so we go to that image property. You'll see that it's rendering the color field, which is coming through these virtual rasters. But then in the time range, you'll see that we've got a whole bunch of events, about 30 or so events. So if I go back to 1974, here we're looking at Landsat 1, right through to 2022, where we're looking at Landsat 8. And then my final time point, it's actually a different rendering altogether. It's Landsat 8 again, 2022, but I'm also putting the NDVI over the top of it. So what's happening when you render this image? Let's just go back to the standard one. So when I zoom in like this on the Collie coal mine, whoops, there we are. What's happening is we've got the original data sitting in TIFFs. That's getting sucked out of there. It's going into a virtual raster where it's being transformed via metadata parameters, scaled and translated. It's then going into a second virtual raster, which is rendering that data in the red, green, blue band combination. It's emitting a raster that has a color data band. That is going into another virtual raster, which records that as a source raster for an event. That's then going into my rendering algorithm, and it's requesting the data. So then finally the rendering engine says, okay, I want to render this event, give me some data, and it goes all the way back, all through that chain of processing operations and virtual rasters until it goes to the original TIFF file and sucks a bit of data out there and puts it on screen. So there's a fair bit of processing involved in that. And that's why, as I zoom out, you'll see gaps there as the threads are slowly pulling the data in. But then as I zoom in, now it's nice and smooth. It's because everything gets cached inside the tile cache. And so once you've rendered it once, everything becomes fast. But if I zoom up here or something, you'll see that, again, there's a delay as it brings in new data that it hasn't loaded before. Once it's in, then things speed up. So just going to finally to the NDVI NDVI. So to compute the NDVI, again, we're using a virtual raster. So let me just drag that one in. Here's the rendering algorithm. Okay, so underneath I have the natural color layer. So there it is. So we'll turn that off, and on the top we've just got the NDVI. So this is generated by ProRaster Scientific. It's a virtual raster again. Puts out a bunch of files, a bunch of fields from that original virtual raster that we generated for the scene. So I've chosen the vegetation field, and in here there's a whole bunch of indices that I can choose, and I've chosen the NDVI index. In here I've activated the masking operation. I've gone back to the original scene virtual raster. I've chosen the mask field, and I'm masking out everything that isn't a clear land pixel. So all your water's gone, all your clouds are gone, and so forth. And then if we look at our color modulation, so in here, so I'm color modulating the NDVI values between 0.5 and 0.8. And you can see here that I'm clipping below the minimum. So everything up to 0.5 is getting clipped out, and then we're modulating up to 0.8. So to try to see some detail in those forests, to see if there was some difference between the rehabilitated mined land and the old growth forests. And you can watch the video to see how that turned out. Well, I couldn't see any difference between it. So that's our NDVI. So as you can see, chains of virtual rasters, everything happening in real time. There's no data duplication. The only data sitting on disk is the original scene data that you download from your satellite data provider. And at the end of the day, it all shows up on the screen in ProRaster Scientific, which will hopefully be available for you to buy by the end of 2022, although it might stretch out a bit longer. Thanks for watching.